Hey everybody, good morning, good afternoon everyone. Thanks very much for attending today's webinar. My name is Mary Benyon and I'm a Senior Manager in ARM's AI Ecosystem Group, and I'll be your moderator for today. So today we have the guys here from Nexoptic. They are part of our AI Ecosystem program, our partner program that we have, and they are going to be taking you through their specific approach to the complicated problems of computer vision at the edge. I'm really looking forward to listening to this because it is tricky stuff. So let me introduce you to, first off, we have Kevin Gordon. He's VP of AI Technologies at Nexoptic. How you doing, Kevin?
Hey, I'm doing good, Mary.
Good. And then we also have Colin Demore. He's a machine learning engineer at Nexoptic AI team. How you doing, Colin?
I'm doing great, thank you.
Awesome. So both you guys studied at the University of Alberta, specializing in computer vision, and you are the co-creators of Nexoptic's intelligent imaging solution, ALIIS.
That's right.
Good job. So before we get started, there's a question mark icon on the right-hand sidebar of the screen, so feel free to ask any questions. Just type it in. We'll get to questions at the end, and we'll try to get through as many as we can. Don't be shy. These are technical guys, so if you have some technical questions, throw them in there. And yeah, so let's stop listening to me. Kevin, Colin, take it away.
All right. Thank you, Mary. And welcome everybody to the ARM webinar. We're happy to be here and tell you a little bit about computer vision at the edge. I'm going to start presenting here. So big welcome to everybody. I know we have Nexoptic investors. I know we have developers and technically minded people and just tech enthusiasts here. So hopefully our talk has a little bit of something for everybody. I'd like to briefly just introduce Nexoptic. We're headquartered in Vancouver, Canada. We're founded in 2016, and we specialize in advanced imaging technologies. And we launched our artificial intelligence about 2 years ago in 2019, and that's what we'll be talking about here today, our intelligent imaging solution, ALIIS. Now, to get into this, I'd like to give a brief history of computer vision, where it started and how it's progressed over the years. And so, really, AI and computer vision have grown up together, starting with the Summer Vision project out of MIT in the 1960s. Researchers have been trying to enable computers with the power of vision. And you know, to highlight just how off we were on our estimates of how long it would take. This was a summer vision project. They thought that by the end of the summer they'd have most of vision solved. And here we are over 50 years later, and we're still working on it. It's a very active field. And it's pretty funny. So the earliest work that, and maybe a prominent work that might resemble what we see in computer vision these days with AI and learning algorithms would be Jan LeCun's LeNet paper in 1989. For the first time, we had a convolutional neural network, a type of learning algorithm, and it was trained with an algorithm called backprop. So really similar to what we see nowadays, and it was used for character recognition, specifically identifying zip codes and on banknotes and letters. And this was a pretty, modest network by today's standards, and compute really wasn't there. It takes about 3 seconds to read a zip code, but really a lot of what we do today looks very similar to this early work. So moving on from this, I guess one interesting point here, there was a quote in this paper, and I'll read it out here. As training data becomes plentiful, as computers get faster, as our understanding of learning algorithms improves, recognition systems will rely more and more on learning, and their performance will improve. And so already back in 1989, we're seeing this learning process, this artificial intelligence creeping into computer vision in a big way. And so we move on. During the 90s and the noughts, there was a little bit of a AI winter for the entire academic field. There's less funding and less press coverage and quite a bit of skepticism around it. But meanwhile, computer vision continued to grow. A lot of hand engineering type algorithms, what we now call classical methods, and also the data sets and compute improved in this time. And it wasn't until about 2012 when researchers at the University of Toronto unveiled ALIISnet. ALIISnet, like LeNet, was a convolutional neural network. It was a learning algorithm, and it's come to be known as one of the most influential papers in all of computer vision. It was a breakthrough. The timing was right. The compute and the data was there finally for these algorithms to really take off. And this algorithm outperformed its competitors by huge margins. Whereas we saw incremental improvements over the years, ALIISnet just blew through these barriers with 10–15% improvements year over year. So this was a real watershed moment, and it marked the start of modern computer vision. And a lot of the solutions out there and solutions that we'll highlight of our own really look very similar to this ALIISnet paper and the LeNet before it. And so why ALIISnet? Why 2012? The biggest reasons is timing. The biggest reason is timing. There was much better compute and there was much better data available. And to put this in perspective, we don't have GPUs in 1989. So I'll use a piece of commodity hardware that we should all be familiar with to just illustrate how much better the compute is. 1990 was the Super Nintendo, and it ran at about 1 to 10 megaflops. You don't need to know what a megaflop is, but it measures the amount of compute a system has. And so 1 to 10, and by comparison, by 2012, when ALIISnet was out, well, actually 2013, the Xbox One came out, we're looking at 1.2 million megaflops. So we're looking at 1 million times more compute. And that's staggering. It's truly unbelievable. Literally exponential growth in computing. And not just compute, but the data sets. We're looking at over 10,000 times more data availability with things like ImageNet, high-quality labeled data. And so really timing was critical here. And another common thread emerges from the ALIISnet paper, and that's all of our experiments suggest that our results can be improved simply by waiting for faster compute and bigger data sets to become available. It's such an important point. The compute is there and the data availability being there. And so that brings us up to modern day computer vision. The stage is set, and we can ask important questions like, in computer vision, what's generating these images and video? Where's the processing happening? How's it being used today? And if there's any issues, what are the issues and barriers? So why is computer vision so relevant today? And again, timing. We saw that compute and data really drive these learning algorithms. Today, there's more images and video being generated on a daily basis than ever before. You think about it in these endpoint devices or edge devices, mobile phones, huge amounts of mobile phones. It seems like everybody has smartphones taking pictures, video, but not just mobile phones. We have automotive industry. Cars have a number of cameras, from surround view to front cameras, lane detection, even self-driving vehicles, camera-based computer vision. We have security, IoT. Think about your doorbell. If you have a smart doorbell, it has a camera in it. There's medical. The list goes on. So huge amounts of images and video being generated daily. And this means more high-quality data for the training of these learning algorithms, and it's happening at the edge. And so with it being generated at the edge, it's only natural to put interesting and useful applications right there at the source. So that's half the equation. What does the compute look like? Well, edge compute now is capable of delivering in ways not possible before. It wasn't just gaming consoles that saw this million-fold increase in compute power, whereas maybe 10 years ago it was difficult to do any image and video editing on computers, nowadays the devices that fit in our pockets are capable of running these applications. So what are some of these applications? I want to bring it down to earth here. You've likely used computer vision today on a daily basis. If you're unlocking your smartphone with face recognition, a Face ID, if your vehicle has lane assist technology in it, that's using computer vision. And then anybody who's on social media, you're posting pictures or videos, I guarantee there's a scary amount of computer vision happening behind the scenes there. So it's not far out tech on the horizon, it's happening right now. And it's making its way into industry, manufacturing, and all over. And so we're able to recognize people and objects. These algorithms can drive our cars, map environments, and help us take better selfies. So that takes us to some of the issues we're facing now, and kind of relevant to the question of where's the processing happening. A lot of processing has happened on the cloud where we have, high availability of lots of compute compared to the edge. But one of the main advantages of processing at the edge and in these endpoint devices is that the data never needs to leave your device. Data locality is huge. Now you're not sending it to the cloud. And what is the cloud after all? It's a computer connected to the internet sitting on someone else's property. So if we can avoid sending it up to the cloud, then this is a possible way to achieve better privacy and security for our data. But that goes into compute. We don't have the same amount of compute on the edge as we do in the cloud. So can we even run these algorithms? They have to be low powered, these devices, maybe battery powered even. You're not likely to find a beefy, several hundred watt GPU in your doorbell. And so compute is a big barrier. You need efficient algorithms and you need good hardware to be able to run some of these more powerful computer vision algorithms. And then there's developer access as well. A lot of the images and video are being generated by these phones or these automotive sensors. Largely they're installed by the OEMs, the original equipment manufacturers. It's a bit of a black box. And so, yes, you can develop applications on smartphones, Android or iOS, but there is this kind of black box technology that's a barrier to being able to audit, to improve code, or just bringing new creativity and applications online. And then there's also a barrier of the amount of data available and to train these learning algorithms. So there's some hurdles to computer vision at the edge, but we think that with the right alignment and partners, this is a very achievable goal. And so that takes us to ARM. This is an ARM webinar. I hope you're all familiar with ARM, but if you're not, please read about the company. ARM's a big deal. I guarantee you use devices with ARM's IP inside. The history and the scale of ARM is truly impressive, and so influential that small changes, small features, year-over-year improvements have guaranteed large ripple effects around the world. And so central to ARM's strategy is total compute. These should be pretty familiar points here. Guiding principles, delivering compute performance, prioritizing security, and enabling developer access. And so with ARM delivering compute performance, we see things like dedicated AI processors, like their Ethos NPUs, and also in their recent announcement of ARM v9, SVE2 is taking a central role there. SVE2, scalable vector extensions, really it's going to allow the CPU to do more AI workloads. So that's lower power, higher performance on the edge for AI and computer vision applications. And SVE2 is important not just from a compute performance, but also in the enabling developer access. Right now it feels a bit like stories from the 80s in the computing world for AI. It's fragmented. For each system you might have to write custom code. just to have your AI or computer vision algorithms working on a device. But with SVE2, we see a more unified ecosystem where one code base is deployable on a whole wide range of devices and endpoints. And then, of course, security. From the ground up, ARM prioritizes security and has even announced recently a new security architecture, CCA, that should be a game changer again in making sure that our edge and endpoint devices are secure, so we can have that data locality and the security at the edge. And so that takes us now into ALIIS, and I'll invite Colin from our AI team to talk a little bit about ALIIS here.
Thank you, Kevin. I'll get straight to it. Nexoptic's ALIIS is a suite of intelligent imaging solutions designed to enhance imaging applications. More specifically, it's a set of learning-based computer vision algorithms that use convolutional neural networks, or CNNs for short, at their core, similar to the popular LayNet and AlexNet Kevin mentioned previously. Unlike the two CNNs mentioned above, ALIIS is not designed to perform classification tasks like object detection or facial recognition. In our case, we are transforming an input image into a completely new image. When we say we've transformed the image, it means we've designed these algorithms to literally enhance each and every pixel they process. In the case of ALIIS Lowlight, which we'll dive in deeper into in just a second, our AI learns the unique imperfections and flaws of a sensor and removes them in real time. Image-to-image CNNs have been developed and experimented on in the research community, but a big factor, other than overall model performance, that separates us from the rest is that our algorithms are designed and optimized for the edge. We've digested all the available literature we can, taken that knowledge, and applied it to optimize ALIIS. This includes methods of architecture searches, model distillation, weight quantization, mixed precision networks, filter and weight-based pruning, along with some other internal methods. We do anything and everything to deliver real-time processing on the edge. In turn, working on the edge comes with a lot of benefits. This includes things like low latency. You don't have to transfer your data far and wide. Data locality, your data's there right where you need it. An increase in privacy, since your data isn't going anywhere. And lastly, but very importantly, access to uncompressed raw data. Raw camera data is extremely valuable and is key to many of the features of ALIIS. Let's spotlight on ALIIS Lowlight. This is software designed to enhance downstream imaging applications. With ALIIS Lowlight, the utilization of edge processing allows us to remove image noise at the source. This means that we can intelligently transform the data at the very beginning of the camera pipeline, which enables us to squeeze every last ounce of useful and uncompressed information out of the raw image. As a result, we send the ALIIS enhanced image through the rest of the pipeline, so everything else downstream can reap the benefits. With regards to ALIIS Lowlight, you can see an example of its impact to the right of the screen. The image was taken on a leading smartphone. The raw, bare image was processed with ALIIS, and the ALIIS Lowlight output was sent through an internal ISP to produce the RGB image you see in front of you. With ALIIS Lowlight integrated into your camera pipeline, you can expect to see enabled use in dark environments or with fast shutter speeds. You can expect about 10 times data compression by removing image noise. You can expect clearer and sharper images. And lastly, you can expect to see a smaller overall energy footprint due to easier data compression. Like previously mentioned, because we're on the edge right next to the source, all these benefits cascade downstream. To drive that point home, say you have a roadside camera detecting cars. Now the shutter speed needs to be quick, otherwise the cars will all be blurry. But that means we don't have a lot of light to work with, which leads to noise, and noise affects the performance of computer vision algorithms. If this noise was removed using ALIIS Lowlight, the AI here will have a much easier time making the correct classification for the task at hand. As a more concrete example, here's an experiment we ran showing a 400% increase in classifier performance. This is a real commercial classifier. People pay good money to this Bay Area company to use it, and through this chart, we show how noise hinders its performance and displays how ALIIS can boost it. Now that you've been introduced to our technology, let's take a look at an ALIIS low-light demo running on ARM. At this point, oh, we gotta get the slides open again. There we go.
And Colin, I think for the audience, we couldn't hear you while the video demo was going, so could you just give us a quick couple notes there?
Okay, yep, for sure. Yeah, what you're seeing in the terminal is the ALIIS command line tool, which in this case uses the Nexoptic SDK to run an image through ALIIS Lowlight, through our internal ISP, and out the other end. The command line tool is compiled for ARM v8 and uses the Android command line tool ADB to run on a leading smartphone. For a apples-to-apples comparison, we loaded the before and after images into GIMP, the open source photo editor, and you could see the difference that ALIIS can make. At this point, you may be wondering about ALIIS working on video. ALIIS currently has video demos of ALIIS working at 1080p 30 FPS on mobile hardware, and expect to get a 1440p solution to follow in the coming months. So, if you're a developer wanting to add or improve to your computer vision application, or you have a product or application that would benefit from computer vision, reach out to us to see if ALIIS will benefit your project. We've done the work of curating the data sets, creating and training AI models, optimizing these models for the edge on a number of leading platforms, and we know that there's enormous opportunity to get the most out of your application with edge-enabled ALIIS. I'll now pass it back over to Kevin to wrap things up. Thank you.
Thanks, Colin. So, to summarize here, I hope we've convinced you that the time for edge and endpoint computer vision is now. The compute is there, the data is there, and there's a host of markets that we believe will benefit from enabling computer vision, from mobile, smart security, AR, VR, medical imaging, and industrial automation and manufacturing. But it's crucial. You need to align with leading core technology providers. ARM is a great example of this, prioritizing performance, security, and access. And you need to pair your application with ALIIS to get the most out of your product. You saw earlier we did 400% improvement on a commercial classifier. You want clear, sharp images, we can do that. Efficient performance on the edge, we do that. And it's not just better, clearer images or selfies. This has cascading downstream benefits. Processing at the edge with that raw data enables much higher quality data downstream, whether that processing's on the edge or even in the cloud. So that's intelligent imaging, and I hope you enjoyed a brief history of computer vision and some of the issues, challenges, and where computer vision is being applied, and learning a bit more about ARM and Nexoptic's ALIIS. So thank you. And please feel free to contact us, advantage@nexoptic.com, if you'd like to learn more or get in touch with us about implementing ALIIS on your next project or your current project. I'll leave this slide up here for a few moments longer so you can copy that email address. It's also available at our webpage, nexoptic.com. And then we'll move to a Q&A here briefly.
Awesome, thank you.
Thanks, Mary.
Yeah, that was great. We do have a few questions that have come in, so we can go through those. Your colleague Paul, hey Paul, and Richard have joined us, so they will be available to help answer some questions. So why don't we, Paul, I'll let you take it and start grabbing the questions that you guys want to get answered now.
Sure. I'm gonna add it to Kevin. I think there's some technical questions first, Kevin. Maybe you want to jump
Yeah,
on.
I saw some great questions coming in, and I'll start with what is the edge? You know, edge is a bit of a buzzword in the industry, but whereas the cloud is this centrally available processing on demand, you can think of edge as, or endpoint as the kind of the opposite of the cloud. Your mobile phone would be on the edge. It's right there at the source. Security cameras right there at the edge generating the data. IoT devices as well. So it's really just a category of devices and in contrast nicely with the cloud. There was also a question about max resolution and frame rate for ALIIS. Really, we support any resolution, so this is all dependent on the hardware. If you know, the more pixels you want to push through the algorithm, the more compute it's going to require. Really, the answer is it depends, but we're not limited to some small resolution. Colin mentioned on mobile, we're doing 1080p video. We can do, you know, 12, 15, 20 megapixel still images on mobile, very efficient. Which leads to another question about power usage on small devices. I would just, my answer to that one would be that the hardware's come a long way. We can do real-time video processing with these neural networks, HD video, and we're in the sub 1 watt regime, so it's, you know, it's not pulling a terrible amount of power for the amount of workloads that we're working on. So, but yeah, definitely there's, it's not just these small devices. Medical's a great, the question had, you know, wouldn't it be more suitable to higher end devices like medical devices or institutional use? So yeah, those are great examples of it, but definitely applicable in these other not so high end areas. Okay, I'm just kind of sifting through here.
Yeah, we've got a lot of really good ones.
Yeah.
What about, let's see, the industrial automation one?
Yeah, industrial automation is really interesting. You know, you have perfect control over your lighting environment for the most part. In some settings, not so much, but you know, if we think about classical industrial automation, we can put as much lights as we need and whatnot. But if you have things going by, even on a conveyor belt example, your conveyor belt speed is kind of constrained by the shutter speed of the camera. If it's moving too fast, you're going to get blurry objects, and so that fast frame rate is required, and then you're capturing less light, less light, more noise. You know, the question is, what levels of ambient noise is it challenged? I'm not sure if that's like what kind of PSNR of noise we're looking for, or what's the, you know, signal to noise ratio that we're comfortable in, but you know, we can put our ISO up to, you know, we're looking at 100 to 600 times just the ratio, not the ISO. So lots of noise we can handle in these scenarios. Maybe get in touch and we can talk about that one more deeply if there's a kind of specific application.
Yeah, we've got up to about a factor of 1,000 or 60 decibels. You know, it's obviously becomes more difficult the higher you go, and it comes with some trade-offs. But
yeah,
we've definitely trained models and got impressive results at those levels.
And then maybe a question for Paul here. A question about, is Nexoptic publicly traded?
Sure, that's an easy one.
Yeah.
Yeah, the answer is yes. We trade on 3 platforms. We trade in the United States on the OTCQB. market. We trade on the Canadian Exchange, Toronto Venture Exchange, and we also trade on the Frankfurt Exchange. So yeah, so it is a publicly traded company. You can buy our shares. We're a very liquid stock. Our market cap is about 75 million Canadian dollars right now. So.
Okay, follow up, Paul. Someone asked, who is Pristine Surgical and how did you come to partner with them? And related, published a news release this morning on Pristine. Is there anything further to that? And can we expect anything more?
Yeah, Pristine is a really progressive, innovative company out of New Hampshire. CEO is Brian Lord. We met them some years ago at CES when our capabilities were not nearly what they are now, but we're a very good fit. They're in endoscopy surgical disposable units, which are very economic and also very practical and speed up the whole process in surgical rooms for endoscopic surgeries. So yeah, we've got a great relationship with them. We love working with them. And yeah, to the point of what that represents, I mean, they are literally the first adopter of ALIIS, but we expect a lot more. We have a lot of other conversations going on right now with a number of other companies, so we expect more to follow.
There's a tech question here on the two-part question. What is the camera being used? I'm guessing that's a reference to the demo we showed, and what is the AI support on ARM? So for the camera, I won't give the exact, maybe it was in the video if you look closely, but it's a leading smartphone, real mobile sensor, and that was captured at night, very low light conditions. So, it says the quality is very low. I think you'd be surprised just how noisy mobile phone sensors are. It's small sensors, and so there's a lot of benefit to using these, low light algorithms for better images. And then what is the AI support on ARM? We target various frameworks, so we can look at TF Lite, which targets ARM very well. And then we're working with other ARM ecosystem partners to, develop ARM-optimized versions of our neural networks. So we kind of have the kind of general case, and we're working to specialize on ARM now.
Yeah, and the question that sort of ties in is when will ALIIS be on ARM chips and devices commercially? And I think now.
Yeah, we are ARM ready.
Yeah.
No products out there yet.
ARM and ready.
Okay, yeah. No, good. Let's see here. Question about Rich. Rich, someone's asking about you previously running a Fortune 500 company. Why Nexoptic?
Oh, sure. Yeah, I was previously CEO of Lexmark, and Nexoptic approached me, and I was curious about their technology, and they flew me up to Canada to review the technology, the product, and the team, and I was just totally impressed with the management, with the quality of the team, the AI expertise, the hires, the resources, and the product itself. It's really at the cutting edge, employing neural network technology, and finally, the marketplace is just absolutely huge for this. Something like Pristine Surgical is just the tip of the iceberg. They'll probably explode because this endoscopy market that's disposable is the whole new wave there. People don't have to redo the the sanitation relative to the scopes. They just throw them out. So, but if you look at markets in military, drones, you look at markets in mobile phones, huge opportunity there. Various things we can do there. We're currently working with several potential customers, collaborating technologically. A very large customer that does kind of management of fleets, buses, police cars, that sort of thing. There is just a huge variety of applications. So I'm very excited about the future of this company. And frankly, Initially, we had a little bit different focus. When I came on board and we then appointed Paul, one of the co-founders and CEO, we took a pivot slightly and focused on the the artificial intelligence and developing the ALIIS platform, which really I think will provide a foundation platform for a variety of market segments. It's very exciting, and I look forward to our relationship with ARM as well, which I think gives us a lot of potential and expands our opportunities quite dramatically.
Thanks, Rich.
Yeah, so we have so many questions, so let's just motor through them. I'm trying to help too. I want to get to some of the technical ones as well as just sort of, the general ones. Let's see, how about the minimum ARM device config is needed to launch? So what's the minimum, what's the lowest you can run effectively ALIIS at this time?
Yeah, again, that one's, it depends. Are you doing just still images? Yeah, if you're doing still images, or are you doing video?
Let's do both. What would be the minimum for still, off the top of your head?
Yeah, in terms of, that one's probably best answered with flops per megapixel. Okay, that way there we can kind of map it to any of these. Colin, what's the latest and greatest here on flops per megapixel?
We're constantly reducing the size. We're trying to, I guess, minimize the compute while maximizing performance. Our latest mobile model is about 16 gigaflops per megapixel, but we are also currently in the research phase of models that are about 4 gigaflops per megapixel.
Yeah, we can expect that to drive lower and lower. So maps linearly. I'll leave the math up to our astute question askers here.
Math people out there.
Yeah, that's right. I did the math.
Perfect. Can you use this for small object detection?
Yeah, so this pairs nicely with object detection. So we don't have an object detection algorithm of our own yet. We're constantly adding features, so stay tuned. But if you have an object detector and it's failing in a noisy environment, you don't have the resources to retrain it for that noisy data set, then absolutely use ALIIS as a preprocessor and expect the object detector to work better. And, small objects, large objects, we preserve resolution or increase resolution, so small objects should be no problem.
Awesome. Yeah. Let's see. How about what does ARM Systems and Standards offer, which NVIDIA and some other competitors don't?
Yeah, that's an interesting one because there's a lot of ARM devices out there, and I think that's probably one of the best ways to look at it is deployed devices. NVIDIA, we're just starting to see things through the kind of Jetson boards moving to the kind of endpoint and edge, but ARM is prolific. They are everywhere. So I mean that's huge. So the current install base, and then also the companies that are ARM based. So ARM offers a huge customer base of deployed edge and endpoint devices. And then beyond that, working with the recent features like SVE2 and ARM NPUs, these offer really effective CV and AI. Yeah.
Yeah, and then our impending upcoming IP that will be released at some point this year. But yeah.
Great.
Let's see. How about somebody's asking if you could expand a bit more on the methodology followed in the slide where you showed improvement on classification after denoise. Did you retain the full network for both cases, denoised and noisy?
Sure, yeah, so that experiment, we had a sample size of about 500 images, and there's just two data sets. One data set was the noisy data, and then the other one was denoised with ALIIS. And black box, we had a commercial classifier, Colin mentioned, from the Bay Area. So this is a production commercial classifier, and we just ran the two data sets through it, the noisy inputs and the denoised inputs. And so that's where you saw the 400% increase in performance there with ALIIS. So no retraining, that was just blind and black box improving a classifier.
Great. Let's see. How about what's the latency time to enhance image as preprocess if we want to use in a real-time application, for example, like self-driving?
Sure, yeah. No, self-driving, definitely stringent on the latency there.
Yeah.
Again, I'm going to answer with it depends, but you know, for example, on the mobile, when we're doing our 1080p video execution, we need to be sub 15 milliseconds for efficient video execuon. So that should give you an idea. Right now, everything's running independent frames, so you can look at each frame taking about 10, 15 milliseconds. But we're working to lower that, and it does depend on the resolution.
Yeah. Let's see. Are there any other ones that jump out at you? There's a couple more kind of investor type questions.
There's a question about vehicle license recognition, which you might want to.
Yeah,
that's a good one.
Yeah, let's see here. Looking for a solution for that. That's a great example because, you know, noise, there's all sorts. It depends if you're fixed mount or if you're mobile mounted license plate recognition, but, you know, whether it's at night or daytime and all these kinds of things. But noise does affect the performance of license plate recognition, or LPR. And running on fairly cheap hardware, there's all sorts of, you know, tricks that you can do to, you know, you can isolate your license plate and then you're not processing the whole frame, every frame, but you can just process the subsection. So I think it's a great application of the technology, and we expect to see similar performance gains like, you know, I mentioned in that classifier experiment. So yeah, let's get in touch.
How about this one? What's the onboarding process like at Nexoptic? So how would somebody get started integrating ALIIS into their product? You mentioned an SDK.
Sure, yeah. So definitely reach out, advantage@nexoptic.com. You'll be put in touch with our business development team. From there, we can start looking at how you can evaluate ALIIS. So there's a few different things we can do, from media exchange, there's canned media and examples, of course, to evaluation kits. And, you know, in some cases, we do have an internal SDK, and we can use that for partner evaluations. And, you know, this ties maybe to another question here. Is it free for the research community? Stay tuned. Maybe sign up for our newsletter so you can learn if that SDK becomes public at some point. Yeah.
Here's one. Do you need to constantly retrain the model? It's a good one.
Yeah. So there's kind of two parts to that. We have matching or characterizing the sensors that we're working with. So we really like to have really finely tuned algorithms for a specific sensor class. In general, it performs quite well, but if you want the very best, get that last 5–10% performance, you're going to want to characterize the sensor. And so that does require retraining. And then there's the second track of the algorithm is constantly improving, from architecture changes to data set improvements. So we basically have a rolling retraining happening, so a constant day-over-day improvement on these algorithms.
Yeah, it's an iterative process. We're always training new models.
Yeah, so yes, if you want better performance on a specific application, and in general, yes, we're constantly improving these algorithms.
Yeah. Quick one, can ALIIS be ported to FPGA platforms with ARM cores accelerators?
Sure, yeah. There's probably a bit of an engineering overhead to accomplish that.
Yeah.
But there's nothing that's a barrier there. At one point, we supported, OpenCV had an FPGA target for neural networks. That would need to be dusted off because we haven't had too many people approach us on FPGA work. But yes, absolutely. And then we have done some work with, you know, FPGAs as prototypes for further ASIC rollouts. So, yeah. Yeah, absolutely.
All right, I'm just doing a quick time check. We're about 15 minutes to the top of the hour. I think we'll hang out for a little bit more to answer questions if everybody is good with that. So let's just kind of continue rolling through these for maybe another 5 minutes or so. see how many we can get through. Let's see. Any word on ALIIS getting into a major mobile platform for public use? Could I purchase a phone with ALIIS in the near future?
Oh, we all want that. We all want
Yes.
that. We got to stay tight-lipped, but it's a great application for it. There's a great fit. Mobile phones have this great, ecosystem around camera features being big differentiators. So that, we think it's a great fit.
And just to, make a point here, that's one of the strong motivations behind opening up our Korea office is to work with potential mobile customers and expand into the Asian mobile community. As you know, the mobile market in terms of volume is just enormous, so it's a huge opportunity for us, and there's several different ways we can serve that community with our ALIIS platform.
Great. Here's one, which, how do you compare your solution with other AI solutions out there? That's kind of very broad, but
Yeah.
yours is better. That's the right answer, right?
That's always the answer.
Right.
We're better because we're at the edge.
Yeah.
We're better. We're working with the raw data. A lot of companies are doing this kind of enhancement, but they're doing it for process media, RGB media. There's a lot to be gained by working at the edge, being close to that source. Take compressed video, for example. We can remove this noise before it gets baked into an H.265 stream, and really once it's in there, it's very difficult to get out. Working at the edge, you might see 10x more bandwidth if you're not taking the noise out. And that can be something like a Zoom call. You have noise in your Zoom call and suddenly you're using 10 times more bandwidth than you need to, or the quality of the call deteriorates. So that's a big differentiator for us. And then a lot of AI solutions are focused on the object recognition and detection, segmentation. They're all great applications. We've chosen to focus on low light, noise reduction, kind of a more fundamental imaging property, so that we can help all these downstream processes. And then we're adding more functionality to kind of be AI for AI. So I think that's kind of our position there.
Kevin, there's a question about can our denoising impact headlight blooming, and I think our anti-glare offering and artifact reduction is something you might want to mention.
Yeah, actually, anti-glare was originally conceived for the automotive use case. That was for either sun or headlights, basically making things like stop signs or object detection and collision avoidance, these kind of a different type of noise entering into the scene so that you can't effectively make decisions or detect these things. So yes, we have an anti-glare offering, which is really just a nice tunable artifact removal algorithm, really well suited to these applications.
There's been a couple of questions around like the partnership with ARM and Nexoptic, and what's the model. So essentially, Nexoptic is an ARM partner in our ARM AI ecosystem program, and really it's for us it's about finding really great tech and solutions that run on ARM, and we love to get them into our partner program and collaborate with them and bringing webinars such as this to everybody's attention to educate people on the technology that runs on ARM. And that's essentially the partnership model, and hoping we can get other people to understand more about the technology so that companies can find our technology partners and start doing business with them. We're super happy when anybody wants to talk to out there in the audience. I would suggest you just get in touch with Nexoptic to learn more. And from an ARM perspective, we just love when companies get together and produce products and solutions that are powered by ARM. So that's the extent of the partner relationship at this time with Nexoptic. Let's see. Let's take a couple more. There's can the solution be used for image analytic products addressing millimeter and small abnormalities? I think we answered that one. That the answer is yes. Unless you want to add more to that.
I think we covered it.
Yeah. Does the technology help with slow motion?
Slow motion, so I'm guessing like really high shutter speeds, really fast frame rates. Yeah, absolutely. There's kind of two directions there, but yeah, with the fast frame rate or high speed photography, you're not capturing a lot of light. Actually, in some of my previous work with an industrial partner, they were doing microscopy as well as high speed photography. And so in that case, you just physically couldn't push enough light into the lens, into the system. So it was noisy. And so absolutely in slow motion, you're going to have that noise. We can enhance it.
Cool. This is a good one. So how big is the ALIIS team, and are you guys able to scale ALIIS to multiple commercial opportunities?
Yeah, great. So ALIIS, the AI team, we're currently 5 developers. We can, we'll be expanding here over the next while. But scaling the solution, we've done a lot of work to make sure that our training regime and our SDKs, API are all, well suited towards developers, developer first. And so this can scale up quite nicely.
Kevin, I'll just add to that. The tech team is small, but they're incredibly efficient, which is obvious here. But we do plan to probably double the size over the next few months. We'll be onboarding new people soon, and then we have, as Rich pointed out, our Korean team as well, who are very connected in the AI space as well. So we have a lot of people to draw on.
Great. All right, let's do a couple more. Do you have different ALIIS models, ML models for different types of pictures, backgrounds, themes, or is it just the same model that is used for everything?
Yeah, each feature has kind of its training regime, and then each feature would have different classes of models, and those classes of models would be for different execution, either environments or like different platforms, or for different size networks. So we train our own networks and we build our own networks. So I'd say there's a different neural network for each feature, whether it's super resolution or it's low light, anti-glare, different network. And then per platform, we might make a custom architecture due to some supported operations and things like that. And then depending on how much compute's available, we might provision more or less networks. So yeah, there's a bunch of different networks, but the best breakdown is by feature.
Awesome. Latest question that just came in, do you have a technical team in Korea? I think the answer is yes. They just answered that. So they do have a presence there. And then just speculative questions, any discussions with Tesla, or is NASA or SpaceX expressing interest in bringing ALIIS to their space programs? So probably questions that you wish you could say yes to, but
there's an Apple car one there too.
We have
Apple car. Yeah.
But we do have a lot of ongoing conversations right now. I guess that's
Awesome. All right. Is there any other question you want to grab before we close out?
There's one here about descriptions of performance, capabilities, and kind of data sheets on our website. Right now, we just launched our new website this morning. It's going to be continually updated here, so check back. We'll have more specs and data sheets that you can find out more on ALIIS in the near term here.
Yeah, there's going to be a lot in addition to the spec and the performance, there'll be a lot more added to our website coming up, so keep checking back.
And then if you've stuck around this long, in the description of the Bright Talk, you should see at the bottom there's a sign-up link, Google form. I encourage you to visit it. It's a giveaway. We ask a couple questions, and you have the option of signing up for our newsletter. But importantly, a chance for winning a giveaway package. So.
Yeah, so for those of you, the little icon, click on that, and the form is at the bottom. So yes, for those of you who stuck around this long, thank you. You are rewarded with this exciting prize opportunity. And I'd just like to thank all of you at Nexoptic. Thank you so much for coming and talking to everybody about your technology today. Really, really interesting. I love what you do. When we've had our first discussion, when you were joining the program, I was just really blown away by the technology. It's super exciting. So thank you very much, everybody. This will be available on replay in about an hour. if you want to watch it again, because it was so great. The slides will be available for download as well. And so, yeah, get in touch with the Nexoptic if you have further questions. Thank you again, and have a good day, everybody. And we'll talk to you again at the next webinar. All right, cheers.
Thanks, Mary. Thanks, our team.
Bye.
Thank you, everyone.